Joining us on WION World is One today is Dr. S. Somanath, Chairman of the Indian Space Research Organization. Sir, welcome to WION. First up, I'd like to ask you about your top priorities as Chairman and some of the visions that you have for the organization, sir.
Thank you. Thank you for me having in this program. This interview is really interesting. Even just at the moment that I have taken over as chairman of Indian Space Research Organization, you are there to ask me a lot of questions, of which I am not fully prepared. But still, whatever experience I have, whatever information I have, I will try to answer them. The most important thing, as you said, it is setting up the priorities. No, it's always priorities that drives ISRO. We always look at all the work that we need to do and then make the list and then do the first thing first. So, of course, the priorities, as I see, is most important thing is to look at what the government wants space sector to be in the future. That they have already announced the opening of the space sector and also set in motion the vision of Prime Minister Sri Narendra Modi in creating large number of space activities in the center. That is his global. You heard today also that he is talking about so many startup companies coming up, and he is very enthused about it. So now coming back to that, I believe that really opening up of the space sector is the most important priority, and enable that to happen. Now there are a lot of things to be done. It's very easy to say that you open up, but then we need to define what are the elements of that opening up. For example, we are expecting the overall space sector will become a bigger, much bigger entity. I used to call it a space enterprise in India. So if this has to happen, Indian Space Research Organization is there as a mother organization. The Department of Space will enable more actors to come into this, which includes the user segments, which are the departments of the government of India, the private entities who are using space-based data products. They will be part of the whole process. The second is the industries who are already suppliers of systems, manufacturers of systems will get in with a larger pie or role that will be there in this. The third, of course, is the new starting companies who are into space business, rocket spacecrafts applications. They will also part of it. Then, of course, the research community or the teaching community or the academic community who are there, who can specifically contribute to innovation, they will also be there. So all of them will become part of this entity, and there, if this has to become, then we need to create a set of policies. We have to create a set of legislations that will enable this coming together possible, and they must realize that there is an opportunity here, and their path to innovation and new entrepreneurship shall not be faced with a lot of obstructions or hurdles. So how to minimize those hurdles? So these are the type of questions which I believe this is not a 1 day work or 1 month work or even 1 year work. It's a long drawn process. So my role will be to set in motion the long drawn process now, so as to see some results in few years of time of new industries coming up ready to actually launching rockets from India, and satellites being built in private enterprises, applications becoming very widely used to meet the entire global demand. This is something which I feel the most important task ahead.
So it's interesting what you said about the private industry. So in that regard, I would like to ask you about India's share in the global space sector being at nearly 2% of the $440 billion international space economy. So in that sense, what would be the aims of ISRO to improve that share of the pie?
See, I will not go into those numbers because numbers are very, it doesn't convey what is needed or what it will be. If I simply say it is going to be 10%, I don't know what it means to everybody. But the most important part is that there are users within this country. Their needs must be addressed, which includes the departments of the government of India, the strategic users, the commercial users, and that use must be fully satisfied in a very economic way, and they need not have to go anywhere else to do that. And the second part is this: you have to understand that the space economy is not depending upon building rockets and satellites alone. The overall economy we talked about around 400 odd billion US dollars. That's what we normally quote that number. In that, the significant part of the money is in the application side, in the user segment side, in the ground segment side, and delivery of the space applications to the user. There the biggest pie lies. So I have to make people understand that the business in space sector lies in that sector, and there we need to act. Okay, for example, the communication segment, satellites will beam the data, but then it has to be made available, reach everybody, and space segment will become the one of the important link of the entire communication network. Communication network is not going to be only spacecraft specific. It will have terrestrial elements, the so many equipments, everything. So that is one part. Similarly, remote sensing data comes from satellite, but then who is going to use the data? You need to process the data, make it available to people, and the whole chain of data availability is the biggest money making machine. So we look at it. Launch vehicle, of course, is the least of the whole money part of it. No, they are very complex. It's very costly to build it, but it is very less profitable for anybody to make money out of it. So it continues to remain as one of the lowest share of the segment of the overall economy, but it is the most strategically important segment of the whole system. So we need to understand the value of each of the segments and pay attention. So I will say try to expand it, but let us not put unnecessary figures in front of us. This is my target. Target is always to expand.
Right, sir. Now I'd like to ask you about ISRO's process of converting the cargo carrier JSLV Mark III into a human carrier, the human rating process. Could you tell us about the significance of each and every test that we are carrying out in accomplishing this Gaganyaan mission, sir?
Part of the human rating is to make the vehicle having systems which are more redundant. That means if one of the system fails, then the next system should take over. And if it also fails, the third should take over and still continue the mission or initiate an abort. So we have been working with the single system many areas and also dual redundancy in some areas. Now in the human rated vehicle, most critical systems are going to be quadruple redundant. There are going to be 4 systems no, so that we will be no way the vehicle will have a possibility to have a major catastrophe.
Sir, we've noticed that over the decades, access to space and per kilogram rate to orbit has been rapidly decreasing. So, what are ISRO's initiatives in that direction to remain very competitive in the international market, sir?
See, this phenomena is not new, that everywhere people are trying to bring down the cost. We also realize that unless we bring down the cost, the access to space will not improve, and correspondingly, the business prospects will not improve. There was a time in which bring in more complex technologies and then make it more no very very reliable. No, that period is over, and now we look at how to make the whole system simpler and then become cost effective. This is one approach. So use more commercial items but build in redundancy and then so that it can be easily produced. So this is one approach. Second approach is to conceive reusability, so that the rocket is a very costly item. So if we can reuse a rocket like an aircraft used for travel, then really cost will come down. So the attempts have been going on for reusability over the years on conventional rocket, not the winged ones like space shuttle. But many attempts faced with failures. But the first person to really succeed was SpaceX in bringing the booster stage back to landing. But he also has rocket upper stages never recovered. So that is going waste. So there are a lot of possibilities to bring down cost further if we can make an entire rocket reusable. So there were concepts of totally reusable rocket, two-stage to recovery. The first stage will go vertically, come and land. The upper stage will go and come back as a winged reuse rocket. So in ISRO, we are already working on the winged part of it. The vertical takeoff and landing is next step that we have to take, where we need to have an engine which is capable of doing such a mission, such a task. So in the absence of such an engine, we will not be in a position to do that. So we will start a technology demonstration program followed by an actual rocket development with the proper rigorous reviews and approvals that are required for it.
So now that we spoke about lowering costs and increasing access, isn't the upcoming SSLV vehicle also an initiative in that direction to make launches very commercial and on demand and pretty much instant when compared to the larger rockets like PSLV and GSLV?
Yes. Of course, in SSLV, the goals were multiple, no, not this alone. Basically, we want to develop a rocket that can be built and operated by industries without having too much of complexity. The rockets, they are complex machines. So if you want to, make it realize this hardware in industry and assemble it and test it and fly, it requires all the skills and expertise a lot of people. So in the current scenario, if you want to develop such a thing, we looked at the rocket in a way it will be significantly simpler than the current fleet of rockets. So SSLV is in that way much simpler rocket. And second aspect is manufacturing point of view. We can do it in smaller industries. Now, we don't need huge complex manufacturing setup to make that rocket. So that is the second aspect. Third is, and we were adopting materials and systems which are lesser complex or exotic than the regular rocket material. So that way it becomes simpler. The third part is it is modularity, that we reuse systems in one stage to another. Hence, that is becoming production friendly. So various elements were built into the rocket design so that once you develop it, it can be transferred 100% to the industry, and they will be in a position to produce and launch. And of course, it is cost effective in that because of all these reasons.
So likewise, with now several space startups coming up in India, how do you see their prospects and how do you see their possibility of launching in the next year or next 2 years?
It's very, very high. The possibilities are always very high because they are very enthused and very active in working on this rocket. Of course, we realize that rocket making is not an easy task. It has its own complexity. There is a lot of knowledge required. That is very evident, in the outside that this is enough. But we working in this realize that there is much more than what is seen outside. They are very small part of knowledge which we learn through many failures. So this knowledge has to be really with the institutions who are working on it, and this share of this knowledge from ISRO is necessary for them to succeed. So we look at it, how this can be made possible. Sorry, in making this knowledge transfer possible to industry. So this is what we call sharing of facilities or knowledge in the open space, opening up, which we are talking about. So I am really looking forward for them to succeed, especially with their own initiatives, but definitely with the support of skilled people, which has been created through the space program.
Right. Sir, you grew up as somebody who was really enthused about the planets and several other elements around us, and reading science books that your father gifted you. And now, in your tenure as chairman, India is looking up to several missions, including Chandrayaan 3, Gaganyaan, Aditya L1, and also collaborative missions with NASA, the Japanese agency, and also the French agency. As a chairman and also as a science enthusiast, how impressed are you, and how ready are you for this kind of a challenge?
See, this is a continued engagement with all the space agencies and science establishment across the world. ISRO has been working with all these people throughout, and we have borrowed quite a bit of technology knowledge from them in engines, materials, technologies, etc. And our liquid engines, the cryogenic technologies, were actually acquired through them, but worked with them together sometimes. But now we have reached a level that we can do it all by ourselves in terms of the rockets and spacecrafts. But with respect to science missions, the collaboration continues to be very, very important because all science objectives are global in nature. There are no specific science requirements for India alone. Now, every knowledge is a universal knowledge. So, in whenever you carry out a science mission, we need to make everybody a part of it, and how to complement somebody else's work in this domain with our addition of work. For example, when we went to Moon, we were carrying a lot of instruments of other nations, and together we conducted experiments which one result is complementing the other results or adding value to the other results. So there can be joint work on this area quite a bit in science domains and futuristic research in various domains. So we will always dialogue with all the potential science establishment across the globe, continue our scientists to work with them, learn together to add value to the knowledge we are creating here. But with reference to the specific needs of the country, that is another matter.
So, and in fact, speaking of international cooperation, Gaganyaan itself is a top example of international cooperation where India is working with more than 6 countries in various domains to actually accomplish the human spaceflight. Could you throw a little more light on the international cooperation, sir?
I need to fully go through the work which has been done in this direction, and us and the new chairman. Let me tell that I am really aware of those the work which is done with respect to the different nations, and we have been trying to acquire some systems for immediate use, and also to have a long-term collaboration, such as working on the astronauts, their training, etc. So there is certain amount of procurement, there is certain amount of technology transfer, there is certain amount of working together between different nations. In rocket design, we have been seeking the support of various countries. For example, I am directly dealing with some of the internal testing which we need to characterize a vehicle and the crew module using various facilities across the globe to test and then give us data which has already been accomplished. So such collaborations we continue, but human space flight mission requires much more no, sharing of knowledge, because there are experts across other nations who can really help us. So we will continue to seek that support from especially US, Europeans, the Japanese, Russians. No, those support are necessary, and more than that, we also need a global support for even actually accomplishing the mission, such as tracking supports, rescue support, which are required in case of regular landing or emergency situations, communication support as network across the globe. So this we will be working together.
Thank you very much, Dr. Somnath. That was, in fact, a very, very insightful interview. And, wishing you and ISRO particularly all the very best for the tenure that lay ahead, and wishing you all success, not just on Earth, but in orbit, be it low Earth orbit or geostationary orbit and even beyond. Thank you very much, Dr. Somnath.
Thank you so much. Thank you.